All right, kids. So you had a take-home problem to do. Hopefully you did this take-home problem. If not, pause me right now, do this problem, and then we're going to go over it together. So last time we continued talking about kinetics, which is kinetic. It tells you the rate of the reaction. And we learned how to write a rate law. And it's really crucial to remember what a rate law is. Basically, what rate law is a mathematical equation that relates concentration and rate. So it's a mathematical equation that relates concentration and rate. And we said you have to do experiment. You have to do experiment in order to be able to write a rate law. You can't just look at an equation and say, this is what I'm feeling. No, you have to do the experiment in order to figure out the rate law, which is look at the relationship between concentration and rate. All right. So I give you this take-home problem and I ask you to write the rate law. So we are going to do this together. And the first thing I want you to do, I want you to write the equation, the generic equation for rate law. We said rate is equal K, which is a rate constant, times the concentration of reactant. Here we have A, B, and C. We looked at the concentration of reactant, not product, because at the beginning you have more of the reactant. Now, the thing is that what now we have to figure out, the orders. We have to look at the order for these concentration. And we said coefficients are not the orders. Coefficients are not the reaction orders. We need to figure out the reaction orders, and the only way to figure out the reaction orders is doing experiment. So far so good? Okay, beautiful. Now, let's do that. Now, the first thing I want to do, I want to figure out the constant for A. What happens to the rate of A when I change the concentration? I'm going to pick two experiments. And we said last time that is not a good idea to have two variables. So you are going to pick two experiments where only one thing is changing. Only one thing is changing. So if I want to figure out what's going on with A, I'm going to, for example, pick experiment 1 and 2. Why 1 and 2? Because in 1 and 2, the C concentration and the B concentration doesn't change. So these two are remain the same. The only thing that is changing is concentration of A. So remember, you want one variable at a time. So one variable at a time. So I'm going to look at experiment 1 and experiment 2 to see what happens. You can follow me so far? Okay, beautiful. Now, let's do this. If I come over here, what is going on here? When experiment 1 to 2, what happens to the concentration of A? You can see that the concentration of A is doubled. Now, what happens to the rate when concentration is doubled? You go from 0.5 to 1. So the rate is also doubled. Do you guys see that? So what's going on here? When the concentration of A is doubled, the rate also ends up being doubled. The reaction happens twice as fast. What does that mean? We talked about this last time. That means this is an order of 1. That's the first order. So far so good? Okay. Now, I'm going to go very slow with kinetics to make sure you understand it. Now I want to look at, I'm going to figure out B. I'm going to pick two experiments when only B is changing. Which are those? Tell me. That would be 2 and 4, because A is not changing, C is not changing. The only thing that is changing is B. Okay? So we're going to do experiment 2 and 4, because the only thing that is changing in those experiments is B. Okay? Now, how are we going to do this? Let's look at it. So what's happening with B? To go from 2 to 4, give me 1 second. Okay, get a different color pen. So to go from 2 to 4, the concentration of B is doubled. Now what happens to the rate. The rate is quadrupled, isn't it? So you go 1 to 2 is times 4, but the rate goes by times 4. That's interesting. So what does that mean? The concentration of B, when you double the concentration, the rate is going to be times 4. What that means is, we didn't have this last time in our lecture, that's an order of 2. So you double the concentration, but the rate goes up times 4. So that was the order of 2. That means that concentration really affects the rate. All right. So now the last one to figure out is concentration of C. So I'm going to get 2 experiments that only C is changing. If you look at it, that would be experiment 1 and 3. If I look at experiment 1 and 3, C is changing, B is not changing, and A is not changing. And that's what you want. Because what you want again, you want only one variable at a time. You want one variable at a time. So 1 and 3, what happens to the concentration of C? What we did here, we divided the concentration of C by 2. You guys agree? Okay. When we divided the concentration of C by 2, what happened to the rate? What's happened to the rate? The rate doesn't change. Do you guys see that? The rate doesn't change. Let me point it out. So 1 to 3, so their concentration went down by half. Now the rate didn't change. The rate didn't change. What does that mean? We talked about this last time. If the concentration of C goes down by 2, but nothing happened to the rate, what does that mean? That means concentration of C doesn't matter. It's not affecting the rate. So it's an order of 0. The concentration of C doesn't matter. It's not doing anything to the rate. You guys are following me so far? Okay. So I'm going to rewrite this equation, and this time I'm going to have the orders. Let's do this. Rate is going to equal K times concentration of A to the power of 1 times concentration of B to the power of 2 times concentration of C to the power of 0. So C does not really affect the rate. It doesn't matter much. Alright, now let's do another part to this problem. I know this wasn't part of your take home, but let's do it. What's the value of K? Can you guys, let's do this together. What's the value of K? Now, to figure out the value of K, you can pick any experiment your heart desire. I'm going to pick experiment 1. You don't have to do that. Any experiment that your heart desire, go for it. Okay? So we're going to pick one experiment, any of the experiment. I'm just going to pick experiment 1, and we are going to plug in these numbers. So for experiment 1, the rate is 0.5, and the concentration of A is 0.25, B is 1, and C is 1. So I'm just going to come here. I'm just going to plug this in. So the rate was 0.50 molarity per second equals K, and then A was 0.25 to the power of, that's molar, to the power of 1 times B was 1.00 molar to the power of 2, and C doesn't matter. I'm just going to cross it out. C doesn't matter. It's a 0 order. It's not going to make a difference in my rate. That doesn't matter. Okay. So, now, easy algebra. So, K is going to equal 2.0. I know you can handle the algebra, but here's what I want you to do. I want you to do right now. Tell me, what is the unit for K? Tell me, what is the unit for K? Okay. Now, how are we going to do this? What is the unit for K? Let's do this one together. Remember, this side has to equal this side. And we know rate is molarity over second, right? Now, I'm trying to figure out what is the unit of K. I know here is molarity to the power of 1. And I know here for B is molarity to the power of 2. And C doesn't matter. So what is going to be the unit for K? And I know I'm supposed to go equal M over S. So what is going to be for the unit for K? You can totally see this probably. So what's going to happen? K is going to be 1 over S times M to the power of 2. Why is that? Here is why. Because now the M can cancel out and you can end up with molarity over second, and that's what you want, molarity over second. So far so good. Okay, so that is my unit. 1 over S M squared. So unit really matter. Okay, so basically the unit for K depends on the reaction order, doesn't it? Yeah, the unit for K depends on the reaction order. I'm actually going to write it down. The unit for K depends on the reaction order, because we have to cancel those out. Now, I also want to mention one more thing we've talked about. I don't want you to forget that. So K is constant, but K is temperature dependent. So if I change the temperature, I'm going to have a different K. And we know when we increase the temperature, the rate is going to go up. I'm going to have a different K. So far so good? All right, beautiful. You guys want to do one more practice problem? Let's do this. Let's do one more practice problem. All right, you know the drill. What you're going to do, you're going to pause this video. I want you to do this on your own. You're going to write the rate law. It's a great practice. We're going to do practice, take advantage of it, and then unpause me. We're going to go over it together. So hopefully this is what you said. You said, I'm going to write a rate law. I know that rate is going to equal K, which is rate constant, times the concentration of A reactant, times the concentration of B reactant. But what I have to pay attention to, that these are going to be to the power of X and Y. Those are going to be the orders. And we said the orders, you can't just look at the reaction and figure out. You have to do experiment in order to figure out the orders. So far so good? Okay. Now, let's figure out the orders. Now, so far I've taught you guys that you can kind of look at it and you can reason it out. Let's do that again. And then I'm also going to show you how you would do it using math, which I'm not a big fan usually using math. But let's do the way I've shown you so far. So if we look at this, so I have A and B, I'm going to pick two experiments let's do B first. Or A, let's do A. So if I want to figure out what's going on with A, I need to figure out two experiments that B is not changing, and the only thing that is changing is A. That is experiment 1 and 3. So 1 and 3, the B is not changing, only A is changing. You good so far? Beautiful. Now, what can you tell me about these two experiments? If you look at it, 1 and 3, the concentration of A is doubled. Now, what happens to the rate when I double the concentration, going from experiment 1 to experiment 3? You can see that the rate also doubles. Okay, so what we learned, that if you double the concentration of A, what's gonna happen? the rate will also double. Well, you know what that means. Tell me, what does that mean? That means what is the rate? That means the rate of A is first order. That means A is first order. You already knew that. Beautiful. Now, let's look at B. To figure out B again, you're going to pick two experiments that nothing is changing except B. So A has to be constant. Now, which one is that? That would be 1 and 2, right? Experiment 1 and 2, A is constant. The only thing that is changing is B. So, what is going on over there? What is going on over there? What do you think? So, if you look over here, going from, let me do this again. Going from 1 to 2, the concentration of B is doubled, yeah? When you double the concentration of B, going experiment 1 to 2, what happens to the concentration of B over here? To go from 0.4 to 1.6, that means the concentration will be times 4. You follow that? Okay, so again, we pick experiment 1 and 2 because experiment 1 and 2, A is constant, only B is changing. When you look at it, the concentration of B goes up by 2. What happens to the rate? The rate goes up by 4. So, I'm going to write this down. Concentration of B, double it. But what happens to the rate? It goes by 4. Isn't that interesting? What does that mean? Now you know that. That means it's second order. That means that A is second order. Okay, that was not bad. We got this down. Okay. Now, the numbers are pretty here. The numbers are pretty. The numbers are nice. You can reason it out. Now, sometimes you might run into a problem that the numbers are not this pretty and you have a harder time to reason it out. If that's the case, what are you going to do? You can also do this using math. I usually love doing this because I don't like math, but especially engineers. If you don't like this, reasoning it out, you can also do it with math. And I'm going to show you exactly how you do that because I want to make sure you know the math. And you can do it if the numbers are not pretty. So, let's look at 4A, okay? So, 4A, we said we have experiment 1 and 3, okay? So then, what I'm going to do, I'm going to compare experiment 1 to 3 or 3 to 1. It doesn't matter which one I'm comparing to figure out what's going to be the order. And what I'm going to do, I'm going to do R3 over R1. You can do it the other way too, but I want to do it this way because the numbers will be a little bit nicer. But the other way, you can do 1 over 3. It would not make a difference whatsoever. You just have to make sure this is a concentration for experiment 3. This is a concentration for experiment 1. And what we don't know what is the order. Okay? So all I did, let me walk you through this. We said that for experiment 1 and 3 was what the A was changing, right? So I'm gonna do a ratio. Do experiment 3 over experiment 1. The rate over rate 1 and the concentration of A for experiment 3 over the concentration of A for experiment 1. And I don't know what X is. Okay? Now, if you look over here, again, we're doing 1 and 3. So 3 is 0.8, 1 is 0.4. So I'm going to come over here and for R3, I'm going to put 0.8 over 0.4 equals concentration of A for experiment 3 is 0.4. For experiment 1 is 0.2. I'm showing you step by step. So 0.40 over 0.20. Okay, and I'm trying to figure out X. Now, if I simplify this, so this 0.8 divided by 0.4 would be 2 equals 0.40 divided by 0.20. It would be 2 to the power of X. Okay? Now, How are you going to solve for x? I'm going to go all the steps. Remember, to solve for x, you have to do log. It would be log of 2 over log of 2. And if you do that, what you get is 1. What you get is 1. And this is exactly what we got by trying to reason it out without using any math. So far, so good. Now, what I'm going to do, I'm going to do the same thing. I'm going to do the same thing for B to convince you that you could use math to do it too, but I like reasoning it out. Hopefully you do too. So for B, which were the two experiments that was only B was changing? The only two experiments only B was changing was 1 and 2. 1 and 2, only B was changing, A was not changing, okay? And again, I'm going to do R2 over R1. If you want to do the other way, that's completely okay. I'm just going to do R2 over R1 because it's a little bit easier math. But it doesn't matter which one you do. And then concentration of B in experiment 2 over the concentration of B in experiment 1. And what we don't know the order. Okay? Alright, again, I'm just going to plug it in. Here, the R2, right? Here's the R1. Concentration of B in experiment 2 and concentration of B in experiment 1. I don't want to lose anyone, so that's why I'm showing you every step. So we do, hold on 1 second, I need to be consistent. So 1.6 over 0.4 equals 0.4 over 0.2. Let me put this up. And I'm trying to find out what is y, which is my order. So now 1.6 divided by 4 is 4 equal 0.4 divided by 0.2 is, you don't need a calculator, you got this, is 2 to the power of y. Now how do I figure out y? Again, just think about the algebra. It would be the log of 4 over the log of 2. Now, if I do that, what I end up getting 2. And it's kind of comforting to me that what I get here, it matches what I reasoned it out. So this is how you would do it using math. And sometimes you have to do this because sometimes the numbers are not nice and it's hard to reason it out. But most of the time, you could reason this out. Yeah, you feel pretty good about this? All right, beautiful. So now, what are we gonna do? This is what it means. Our rate law is K times concentration of A to the power of 1 times concentration of B to the power of 2, right? These are the ones that we just figured out. Yeah, okay. Nice job, nice job. Now what I want to do, I want to add a part 2 to this, okay? You could always get more practice. Here's what part 2. Let's do nothing but practice today. What will be the initial rate if concentration of A equals 0.50 molar and concentration of B equals 0.8 molar. Okay? Okay, I have a rate law. That's half the battle. That's good. Now I want to know what's the rate if those are the concentration. So I know the rate law. There is one more piece of information I need to figure out. And the one other piece of information I need to figure out before I can do anything is figuring out what is my K, right? So I have the rate law, but I don't know what my K is. So I need to figure that out before I can do anything, okay? So let's do this. We're going to figure out K. It's the same as before. It doesn't matter which experiment you pick. Pick one experiment. Just for fun, I want to pick experiment 1. But you can pick any of the experiment that you like, whatever your heart desires. I'm not judging you. And then plug in those numbers. So I picked experiment 1. So I'm going to do the rate of experiment 1, the concentration of B for experiment 1, and the concentration of A for experiment 1. So the rate is 0.4 molarity over minutes. The rate was given to you, equals K. A has a 0.20 concentration to the power of 1. And hold on, let me put the molarity. There we go. Times B also has a 0.20 concentration to the power of 2. Yeah? Okay. Now, if you do this, what you end up getting for K, again, the algebra, you got it down. I'm not worried about you for algebra. You get 50. But what I want you to figure out right now is to figure out what is the unit for K, because we said the unit for K is going to change depending on the orders, right? Depending on the orders. Now again, remember what we talked about. This, what did I just do? Remember what I talked about. This entire thing has to equal to molarity over minutes. Do you agree? I don't know the unit of K. I know A is m to the power of 1. I know B is m to the power of 2. So how do I cancel this out to end up with this? Okay, so it seems like the way to do this, it will be 1 over m squared times minutes. Okay, because if I do that, then what's going to happen? If I do that, then the 2m squared are going to cancel each other out. What I end up with molarity over minute, and that's what I want over here. So this is going to be 1 over m2 times minutes. Now there's another way of writing this, and I want to do that just to make sure if you see it in your textbook or some other place, you don't get confused. Instead of doing 1 over, I can also say m to the minus 2 times minutes to the minus 1 instead of doing 1 over. But you already knew that, yeah? Okay, so now that I have K, I have everything for the rate constant. So now I can do and I can plug in and do anything that I want, and I can figure out. So I'm going to rewrite the rate equation. So rate is going to equal 50, because that is my rate constant, times concentration of A times concentration of B. Now let's plug it in. The question asks you, what would be the initial rate if A is 0.5 and B is 0.8? So I don't know what my rate is. 50 is my K. Now my A is going to be 0.50 to the power of 1. My B is going to be 0.80 to the power of 2. I'm just going to add a 0 over here. There we go. So far so good. Now all I have to do is to plug it in. And if I plug it in, what I'm going to get for rate, I'm going to get 16. What is the unit? The unit for rate is, you know it, the unit for rate is molarity over minutes. That doesn't change. Rate is always concentration over time. So that is going to be my final answer. Sounds good? Oh boy. Okay, so we did a lot of practice problem, but I'm really happy we did this. Hopefully you feel pretty confident with rate law. Now, one thing that I want you to remember before we do our next lecture is that rate law relates concentration and rate. Relates concentration and rate. You remember that for me? You'll have an easier time next lecture. All right, kids. I will see you guys next time.